The greatest common divisor for two numbers is the largest integer by which the two numbers can be divided without a remainder. So if you look at this for two sort of small numbers, one way you can get the greatest common divisor is to get all the factors, all the prime factors for each number, and look for as many common prime factors as you can find, and you multiply those together and you get the greatest common divisor. So the greatest common divisor for 12 and 30 is 6. That's a pretty simple example. But what if you have two larger numbers? Well, you can still start from the lowest primes, 2, 3, 5, 7, and so on, and eventually get all the prime factors for those numbers and multiply those together, and then you can get the greatest common divisor. Now that works fine for these numbers, but supposing you have these really enormous numbers, then it starts to get a little out of hand. Now you can do some simple stuff like the number on the left, we see that it ends in 25, which means that it's going to be divisible by 25 or 5 times 5. And the number on the right, if we add up all the digits, we see that they add up to a number that's divisible by 3. So we know that number, that one of the factors is 3. But beyond that, there's really not a lot you can do. So what we have is the Euclidean algorithm, which tells us how to find the greatest common divisor in a much more direct way for any two numbers. And it works like this. You take the larger number and divide it by the smaller number, and you get an integer with a remainder or a mod. So in this case, the answer is 1 with a remainder of 1330. Then you take the smaller of the two numbers that you just divided and the remainder, and you divide one by the other, and now you get another remainder, in this case 399. So now we take 1330 and divide it by 399, and we're going to get 3 mod 133. And now we take 399, divide it by 133, and look at that. The answer is 3 mod 0. Now when you get a 0 as the remainder, this means you're done. And the greatest common divisor is the number that you just divided by, in this case 133. So that's how you can get the greatest common divisor for any two numbers. Now supposing you have this really huge number like this, when you go through the whole formula, this is what you come up with. Now this is a pretty straightforward formula. It's actually simple enough that you can do it in Excel if you want to, or you can write a little C++ program that does this. Or you can do it by hand. It actually doesn't take that long. The point is that this is a much faster method of finding the greatest common divisor. So here we go all the way through and we find that the greatest common divisor is 3. Now I've tried it with a different number on the left, and we've gotten all the way through, and we find that the greatest common divisor in this case is a 1. This is a very special case because it means that these two numbers don't have any divisors in common. So because the greatest common divisor is 1, this tells us that these two numbers are relatively prime. Relatively prime means that you've got two numbers that have no factors in common. So we'll take a look at that in the next video.